Hello students, welcome to physics class. Today we discuss the term energy. We know that the life is impossible without energy. The demand of energy is ever increases. We are getting energy from various sources. We know that the sun is the biggest source of natural energy. We are also getting energy from the tide, wind, from the nucleus of atom, etc. The energy of an object is measured like this way. The energy of any body is defined as its capacity or ability to do work. The energy of a body is defined as its capacity or ability to do work. If an object possesses energy, it can do work. For example, a moving object, a fast moving cricket ball. When a fast moving cricket ball hits on a player, certainly the player will injured. This is because of that ball is doing some work. The ball is able to do work because it possesses some energy. So the energy of any body is defined as its capacity or ability to do work. If an object possesses more energy, it can do more work. And energy is measured in joule. The SI unit of energy is joule. We know that the SI unit of work is also joule. As the energy is the ability to do work, we are also measuring the energy in joule. The symbol for joule is capital J. And see, 1 joule of energy required to do 1 joule of work. For doing a 1 joule of work, 1 joule of energy is required. And we know that energy is a scalar quantity because there is no direction for energy. Work is a scalar quantity. Similarly, the energy is also a scalar quantity because there is no direction for energy. It have only magnitude. Now see, there are different type of energy. Energy has several forms. We are very familiar with the mechanical energy, sound energy, heat energy, light energy, electric energy, nuclear energy. Like there are many forms of energy in our nature itself. Out of this, we are going to discuss about mechanical energy only. Mechanical energy. Let us see what is this mechanical energy. Energy produced by mechanical means is called mechanical energy. Energy produced by mechanical means is called mechanical energy. The mechanical energy are mainly in two types. One is kinetic energy and potential energy. Mechanical energy are in two types, kinetic energy and potential energy. First, let us see what is this kinetic energy. The energy possessed by a body by virtue of its motion is called kinetic energy. The energy possessed by a body by virtue of its motion is called kinetic energy. When a body is moving, it possesses some energy. That energy is called kinetic energy. For example, a moving hammer drives a nail into the wood. Actually, the hammer in motion is doing work. Once it is doing a work, we can say it possesses some energy. A moving hammer drives a nail into the wood. So as it is a work, we can say that hammer possesses some energy. So the bullet fired from a gun can pierce a target. It's also work. The bullet is piercing the target. It's a work. So the bullet possesses some energy. A fast moving stone can break a window pane. A fast moving stone can break a window pane. It's also work. So this stone has some energy. So if you are comparing all the situation, we can say all are in motion. The hammer is in motion. The bullet is in motion. The stone is in motion. So the bodies are in motion. So they possess some energy, and that type of energy is known as kinetic energy. The energy due to the motion of an object is known as kinetic energy. Now let us find an expression for the kinetic energy of a body. Or what are the factors which affecting the kinetic energy of a body. For that, suppose here we have a body of mass m lying on this horizontal surface. Initially, it is at rest. Initial velocity u is equal to 0. We have an object of mass m on this horizontal surface. Its initial velocity u is equal to 0. A constant force F acted on this body. So the body displaces through a displacement or distance S. So this is the final position of the body. The displacement is S. But because of this constant force acting on the body is accelerated. Let us say A is the acceleration for the body. A is the acceleration. Once you know that, once a force is acted on a body, it gets accelerated. Let us say A is the acceleration produced on this body. And S is the displacement. S is the displacement. A constant force F acted on a body which displaces the body. S is the displacement and A is the acceleration. V is the final velocity. But remember, initial velocity is 0. Now, by equation of motion for constant accelerated motion, we can write V square minus U square is equal to AS. V is the final velocity, U is the initial velocity, A acceleration, and S is the displacement. V square minus U square is equal to 2AS. But U equal to 0. In this situation, U is equal to 0. So we can write this equation as V square minus 0 square is equal to AS, or S is equal to, rearrange like this way, S is equal to V square by 2A. S is equal to V square by 2A. And we already know that the force acting on a body is equal to mass into acceleration produced in that body. F is equal to m into A. Now substitute these two equations 1 and 2 in the equation for the work done. This force, applied force, is doing some work. So the work done can be written as the work is equal to force into displacement. F into S. Once the body is acted by a force and it displaces, so work is done. So work is equal to force into displacement. So work is equal to force. Substitute for force. Force is equal to m into A into displacement. Displacement is equal to V square by 2A. V square by 2A. So work is equal to half m. A and A getting cancelled. So half mv square. This is the work done by the external force. So we already know that the ability to do work is known as kinetic energy or energy. So the external agent is doing some work. So he is expending his energy for performing this work. The external agent, whoever applied the force, spent his energy to move this body. So his energy is doing some work, or we can say that the work done is equal to the kinetic energy, or the energy spent by the applied force, or the work done is stored as kinetic energy in this body. The work done by the external agent is stored as a kinetic energy in this body. So this work done is equal to energy achieved by this body. So we can write the kinetic energy is equal to half mv squared. The factors affecting the kinetic energy are, one is the mass of the object and another one is the velocity. The kinetic energy is directly proportional to mass. It means when mass increases, the kinetic energy is also increases. For example, if two bodies having same velocity, one is heavier and the other one is lighter, we can say the heavier one having more kinetic energy, because kinetic energy is directly proportional to mass. The second thing is the kinetic energy is directly proportional to square of velocity. Once velocity increases, kinetic energy also increases. For example, if you are comparing a bullet and a stone having same mass, you know that bullet having a very high velocity. Suppose the stone is having a very small velocity. Both having same mass. The bullet can do more work because it possesses more kinetic energy as its velocity is very huge. So the factors affecting the kinetic energy are, one is mass and the other one is velocity. The mass and the velocity. Kinetic energy is directly proportional to mass and kinetic energy is directly proportional to square of velocity. Now let us see another important type of energy, mechanical energy, that is potential energy. The energy possessed by the object by virtue of its position or configuration is called potential energy. It is a mechanical energy due to the particular position of an object or due to the particular shape of an object, the object possesses some energy. Such energies are known as potential energy. Let us see some example for potential energy. The potential energy of water stored to a great height in dams is used to run turbine for generating hydroelectricity. In dams, we know that the water is stored to a great height. Once the water is falling down, it can run a turbine. By using this turbine, we are generating electricity, hydroelectricity. So the water stored into a particular height possesses some energy. Can we call it as potential energy of that water? Now, a stretched bow possesses a potential energy. As soon as it releases, it shoots the arrow in the forward direction with a large velocity. So because of the shape of the stretched bow, it possesses energy. It can do work. So that are the some example for potential energy. It is the energy possessed by the object by virtue of its position or configuration. Now, different types of potential energy are there. Some types of potential energy are gravitational potential energy, elastic potential energy, electrostatic potential energy, etc. We are discussing only potential energy of an object at a height, that is gravitational potential energy. Gravitational potential energy. Gravitational potential energy is the potential energy possessed by the object by virtue of its position above the Earth's surface because of the gravitational field. Now let us see an expression for the gravitational potential energy or potential energy of an object at a particular height. Initially, suppose we have an object of mass m. This is the horizontal surface of the Earth, the surface of Earth. Here we have an object of mass m. By applying a force, we are lifting this object to a height h above the ground. This is the final position of the object. It is lifted to a height h above the ground by applying an external force. So the body is displaced. The displacement is h. We know that Earth attracts this body of mass m towards it with a force of m into g. So if you want to lift the body without acceleration, the minimum force required for that process is m into g itself. The force required to lift this object without any acceleration is the downward force, that is mg. This much attraction is there, but if you are applying an opposite force of m into g, we can lift that object. So the minimum force required to lift the object is equal to F is equal to m into g. Now let us calculate what's the work done for this process. What's work done? Work done is equal to force into displacement. The force into displacement in the situation is h. So F into h. So work is equal to F is equal to m into g and displacement is h, m, g, h. So this work done is stored as potential energy of the object. The work done initially, there is no energy. Once it is in ground, it was at rest. Its position is on the ground, so it does not possess any energy, kinetic energy or potential energy. But it is lifted to a height h. It gains some energy. Whatever the work done by the external agent is stored as an energy. So energy, potential energy of this object is equal to mgh. That is potential energy. You see that potential energy depends on the mass of this object. Potential energy is directly proportional to mass of the object. Then you know that g, acceleration due to gravity, is a constant at a particular place. And another factor is the height above the Earth's surface. The potential energy is directly proportional to height. When height increases, potential energy also increases. When mass increases, potential energy increases. The potential energy directly proportional to mass and height. But you see, it depends only on the height. So we can lift this object in different way to reach the same height. Suppose we can take the object to this height directly in a straight line path. Or otherwise, first if you are lifting this object to a point A and then to a point B, then final to a height H. We can displace this body to a height H in different way. Either you can direct path, this path can be selected, or this second path can be selected. But it does not depends on the work done, or potential energy does not depends on the path along which the object is displaced. It depends only on the final position because it depends only on the height. It does not depends on the path along which the object is taken to that point. It depends only on the initial and final point. So that's about potential energy. Potential energy is the energy possessed by the object by virtue of its position or configuration. And we find an expression for the gravitational potential energy. Gravitational potential energy is equal to mgh. That's all about energy. Thank you.